When I usually say trigonometry to students, there's usually a cringe that kind of goes through them, and they look at me like, oh, I hated trig. But my hope is that at the end of this unit, you will not only have a very good handle and a very good understanding of what trigonometry is, but you also will have some quick and easy ways to be able to not only draw the graphs, but to evaluate trig questions so that we can do it efficiently. Now, the first part of trigonometry that we need to understand is it's basically comprised of two functions. You might think two. What about the third one? Well, the third one actually is a function of the other two. So trigonometry, in a nutshell, is comprised of sine and cosine. So it's very, very important that we understand those two graphs. And of course, the two functions I'm speaking of are sine and cosine. Now, the first graph, I want you to understand, if I'm to evaluate that first graph, and a graph is a picture of the solutions, then what I'm basically asking is, what is the sine of 0? What is the sine of 90? What is the sine of 180, 270, and 360? Because those are our pivotal spots. Those are the intercepts and our max and mins. I know that sounds kind of, I don't know, arbitrary right now, but they really do matter. And those are how I'm going to look at these graphs in the future. So the sine of 0, if you recall, is in fact 0. And the sine of 90 comes right up to 1. The sine of 180 comes down to 0 again. And then, does anybody remember what it does? Hopefully you're thinking, yeah, it goes right back down. And it completes this cycle. Now, even though I haven't drawn it, it is true that the sine curve continues to do that oscillating over and over, and it does it that way, forwards and backwards. So those are important pieces to know. That being said, it's important to know where these values are. I said 0, 90, 180, 270, and 360. And the truth of the matter is, in pre-calculus, we will no longer use degree mode, so to speak. You'll find that radians are far more accurate. And if you remember when you learned about the trigonometry before, we noticed that in that cyclical pattern, it's actually like a circle. It keeps going around and around and around and around. And if you think about your quadrants and what that looks like, all of this should kind of make sense. Well, why is the pi important? Well, if you remember when we're dealing with pi and circles, they kind of go hand in hand. There is more to it than that, but I'm just going to kind of give you just a surface level of understanding on that. So for today, and probably today only, I'll interchangeably use degree and radians, but I want you to get familiar with the idea that we're only going to be using radians in this class. And so to start, sine of 0, 0 radians, 0 degrees is the same thing. Right there is 0. The first intercept we come to is right there at the halfway spot. If you think about, it takes the whole sine curve to complete an entire cycle from 0 to 360 degrees. That's 360. So halfway would be 180. That should only make sense there. Half of that is where the maximum is located, and that is, of course, 90. So if you use that pattern, you have 90, 180, add another 90, and that gives you, 270. And then add another 90, that gets you back to 360. Well, what does that look like in radians? If you can recall, 360 is 2 pi. So halfway, or 180, is pi. Half that, again, you get pi over 2, which should make sense to you. So we have pi over 2, pi, so 2 pi over 2. 3 pi over 2 is 270. Notice the pattern. Pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2 would bring us right back to 2 pi, obviously by simplifying. How high and how low does the sine curve go? 1 and negative 1. So if I was to ask you the question, what's the sine of pi? What we basically would do is we'd say, okay, the sine of pi, that means on my graph, I'm going to find where pi is located, and I notice, it's at 0. If I asked in a similar way the sine of 3 pi over 2, we simply go to 3 pi over 2 on our graph. I look down here at the graph, it's at negative 1, and so therefore the sine of 3 pi over 2 is negative 1. Hopefully that's enough examples for you to be able to answer number 2 in your homework assignment, which requires you to be able to just simply read off the graph, because that's what you'll be doing tomorrow. Now, cosine, in a similar fashion, has a cyclical pattern. It, too, goes around and around and around and around. This one, however, instead of starting at 0, cosine starts at 1. And so we're going to start at 1. We come down, we go back up to where we started from. Again, those spots that we really need to make sure we know are found right here at the end, of course, again, is 2 pi, or 360 degrees. Halfway is pi, or 180. So the first intercept in the cosine curve actually occurs at pi over 2. And then, so we have 1 pi over 2, 2 pi over 2 brings me to pi, 3 pi over 2 points out the next intercept that we see there, and then we have 2 pi. Well, how about my y-intercept? How high and how low does this go? A typical cosine curve goes from 1 to -1. Now, obviously, although it would be nice, it doesn't stay that way. Our trig functions actually do take on different forms. In particular, we'll see like a number in the front of the trig function itself, and then we'll see a number in front of the x. Something like, oh, y equals 3 cosine 2x. And all that this basically is giving us is some information about that cosine curve. The cosine still takes on the same form. However, the 3 and the 2 vastly change it. The 3, or the A, represents the amplitude. And what does amplitude mean? How high and how low the graph will go. Good. This is basically your height of the graph. B represents the frequency. How often, how many times the cycle will repeat itself between 0 and 2 pi. Now, with that being said, and probably the most important piece of this is, I want to know, how do you figure out then, how much or how long does it take for it to complete one cycle? That is called the period of the function. And the period of the function is found by looking at what the typical length of the interval is, which is 0 to 2 pi, and dividing it by the frequency. So, and that's what B is, right? So that's what we're getting that number from. So if I'm looking at the example that I have up here, y equals 3 cosine 2x, we know that it's going to go up to 3 and down to -3. That's your amplitude. And this tells me that there's going to be 2 cosine curves between 0 and 2 pi. The period of this function would be 2 pi divided by 2, or rather pi. In other words, it completes one cycle by the time it gets to pi. Now let's look at some further examples and actually see how to graph this, or my process in graphing them. So if I had y equals 2 cosine x, the approach is going to be this. Once you see that cosine function written there, the first thing I want you to do is just draw the cosine curve. And just stop there. Now look at the other information that you see there. The only other thing that's changing this is that 2 out in front. And that 2 is representing the amplitude. Wonderful. Which means, how high does this go? Good, 2. And how low? -2. We want to indicate that on the graph. Now the truth is, if it stays at 1 to -1, I don't mind that you don't label it, because it's just understood that that's what it's doing. But keep in mind and be warned that if it's something different than 1, you need to make sure it's on the axis, because if it's not, then you'll be marked wrong, and you basically have not done the graph correctly. Now back to this particular graph, we have y equals cosine x. You'll notice that the frequency of this graph has not changed. So that means I now need to just label all the rest of these parts. Again, it ends at 2 pi, because nothing changed that frequency. So halfway is pi, half again is pi over 2. Using that pattern, 1 pi over 2, 2 pi over 2, 3 pi over 2, and then 4 pi over 2 completes our graph. So that is your first graph, y equals 2 cosine x. Let's do the second one. Number 2 says y equals cosine 2x. Looks pretty close to the same thing. I mean, it's just got a 2 in there. But where that 2 is located changes this graph immensely. Again, we want to start the same way, though. We're going to still start with our cosine curve. This time, however, I want you to think about what's the amplitude. What is the number that should be on the y-intercept here? Wonderful. Remember, there was no number here to change the amplitude, so it must then be understood to be 1 to -1. This 2, however, represents the frequency. And so therefore, to determine where one cycle is completed, because that's what we're looking at here is one cycle, where is that last number going to appear? That last number appears when we take 2 pi divided by the frequency. And so in this case is 2. And so what that says to me is that the frequency, or one cycle, is completed by the time we get to pi. So what we're looking at here is this pi is representing the end of the cycle. So then you might ask, well, then how do I figure out the rest of this graph? Well, we're going to split it in half, because that's where we're going to mark. Halfway of pi, or half of pi, is pi over 2. Now this next mark, or rather the first mark that you see in the graph, is half again. Notice this is split into quarters. So we're going to split it in half again, or rather divide pi over 2 by 2, and we would get pi over 4. So I have 1 pi over 4 using the same pattern. This would make this 2 pi over 4, and yes, that simplifies to be pi over 2. That makes this spot here, the next intercept, 3 pi over 4. If I continue in the pattern, I'd get 4 pi over 4, which does in fact simplify to be pi. And that's how we form that graph. Now let's look at this next one, which looks really cumbersome. And if I was to give this to you last year, probably many of you would have skipped it. Let's be honest. But I'm going to show you, with using this method, it's so much simpler than what you really have done in the past. Okay, so what function am I going to draw first? Wonderful. How high and how low does this graph go? Wonderful. The amplitude in front there, that 3, indicates that it goes up to 3 and down to -3. Now we've got to figure out this ending number where one cycle is complete. So I take 2 pi and I divide it by the frequency 2 pi to find out that this cycle actually repeats itself, or starts to repeat itself after pi. And so what I'm going to do then is I'm going to label this, at 1, not pi. Sorry about that. We got to erase that. And so that's 1 there. So that means that this mark, remember, it divides into halves, right? And then in half again. So half of 1 is 1/2. Half again is 1/4. And now we use that pattern. 1/4, 2 quarters, 3 quarters, 4 quarters would bring us back to 1. And that is the graph of y equals 3 sine 2 pi x. Hopefully that's enough of a example for you to be able to be productive tomorrow in class. And if I did assign the additional number 1 and number 2 in the packets. I believe, though, tonight you have simply the video to watch. So please make sure you write down these examples. And for tomorrow's class, as part of the notes and what I'm going to be looking for, I would like for you to now try one on your own. I would like for you to try, let's try 3 sine x. Have that graph ready for me for tomorrow's class. Great. Good luck.